Okay, so we're back with the second segment of this Chapter 6 video. So we're going to go ahead and do that second example on the bottom of page 1 of the Chapter 6 notes. Again, it's just like the example we just did, where we're trying to find the slope of the line that contains the points -2, 4, and 2, 2. So again, as we were saying at the end of the last one, I can do y minus y, x minus x, or I can do y minus y, x minus x. I just can't subtract in one direction for y's and the other direction for x's. You have to be consistent. So if I choose for this to be x1, y1, and this to be x2, y2, I'm going to do y2 minus y1, x2 minus x1, so 2 minus -2. When you have negatives that you're subtracting, just make sure you're getting everything in there. It's not 2 minus 2, it's 2 minus -2. So 2 minus 4 is -2, 2 minus -2 is like 2 plus 2, which is 4. That would reduce down to -1/2. Okay. If I did a little sketch just to kind of see for myself what's happening here, one point is -2, 4. The other point is 2, 2. You can see that this line does have a negative slope. So it's going the way it should, because I can make an N out of that line. So those two things go together, the slope and where the points are. Okay, let's flip over to the next page. Now on the next page, there is a graph already drawn in there. So it says to determine the slope of the line shown in the graph. Can you think of two different ways you could do this? So I'm just going to kind of explain it with you looking at the notes. There's already a line drawn in that graph. So what you want to do is find two different points. Okay, if you look at that line or any line, sometimes it goes right through an intersection, right? So in our grid, we have all these little lines drawn in. So sometimes a point goes right through an intersection like this, and sometimes, in some, like right here, it doesn't go through an intersection, right? So we want to look at the ones where it goes right through an intersection and use those. There are several of them on that graph. I, for example, was going to use 0, 2, so if you find that one, and 4, 10. But you can use any pair of points, okay? On a linear equation, any pair of points is going to give you the same slope. So those 2 points you're using, one way you could find the slope is to use the slope formula, plug in. The second way is just to start with 1 point and just count to the next one, rise over run. In this case, it's going to be a positive slope. Okay, so again, you can try that on your own, and you can check the uploaded scan of the notes, which will be on Lumen. All right, so let's now get into the bottom of page 2, which is really the meat of this chapter. And that is slope-intercept form of a line. And this is something that often students kind of remember. Maybe you don't remember all the details about how to do it, but often people remember something about y equals mx plus b, okay? And we call this slope-intercept form of a line. Form just meaning this is one way to express the equation. Slope-intercept because the m stands for slope, just the m, not the x, and the b stands for the y-intercept. So think about in football an interception, right? Quarterback throws it and someone from the other team comes in and gets the ball. They kind of cross. The ball and the other team cross there. Okay? The y-intercept is the same idea. It's where your line crosses the x-axis. Oh, sorry. I meant to say the y-axis. The y-axis, that's why it's the y-intercept. There is an x-intercept also, but we don't care about that right now. So it's where the line crosses the y-axis. Okay, so remember we said before that if I have just 1 point on a grid, I can have an infinite number of lines that go through that. But as soon as I have 2 points, there's only one straight line I can draw through there. So that's what this is going to do for us, okay? When we have it in slope-intercept form, the y-intercept gives us 1 point, and then the slope is going to help us get to another point. And then we're going to have 2 points, boom, we can draw our line. So this first one on the bottom of page 2, first of all, just asks you what are the slope and y-intercept of this equation. 3x plus 4y equals 12. Okay, so if you remember in chapter 3 when we were solving equations, we worked on solving for a variable when there was more than one variable in the equation. And then last chapter when we were plotting points, we also worked on putting our equation into a form where y was by itself. And at that point I even mentioned, start putting the x term first to get used to it. This is y. So I want to get y by itself, so I'm going to move this by subtracting 3x. 4y equals negative 3x plus 12. I want to get y by itself, so now I have to divide. So y equals negative 3/4 x plus 3. Okay, I'm dividing every term separately over here on the right so that I have 2 terms here. So this is in slope-intercept form. So now I can just read off my slope is negative 3/4. Right? No x in there. It's not negative 3/4 x. Just the number part is my slope. My y-intercept, which we call b, is 3. Okay, so if I want to find the slope-intercept, or the slope and y-intercept, I cannot do it in this format. I have to get it into this form, getting y by itself, x term constant. X term is going to be the number in front of the x is going to be my slope, the coefficient of the x. This constant term is going to be my y-intercept. It's okay if your slope is a fraction. We actually want it to be a fraction when we are graphing, right? Rise over run. We want 2 points there, 2 parts to that. Okay, let's look at the next page. It says graph each of the following. Use slope-intercept form of the line to find 1 point, the y-intercept, then use the slope to move to another point. So the first one there is y equals negative 3/4 x plus 2. So it's very similar to this one, right? In this case, my slope is negative 3/4 and my y-intercept is 2. I don't have to do anything with this equation because it is already in slope-intercept form. So what I'm going to do, again, like as the directions said, I'm going to graph the y-intercept first. That gives me a starting point. Okay, so I'm going to use this little grid because it's a little easier for you to see. So I'm going to graph my y-intercept, and that is 2. So remember, that's where it crosses the y-axis, positive 2. So I'm going to put a dot right there. Then, if you look at what our slope is for a second here, negative 3/4. I still myself write rise over run next to it. Makes it a little easier for me. Okay, put the negative with one or the other. So I always put it on the top. So a rise of negative 3 means we're going to go down 3. And then a run of positive 4, positive goes to the right, means I'm going to go right 4. So I start at this line, or this point, sorry. And my rise over run is down 3, so I go 1, 2, 3. And then my run is positive 4. 1, 2, 3, 4. Now, with 2 points, I can graph a line. Sometimes just for ease of actually graphing and making it look nice, it's nice to have another point though. So I can do it again. Down 3, right 4. Now sometimes, for whatever reason, you'll put your y-intercept and it'll be really high up or really low down on your graph and you won't have room. Let's say my y-intercept was negative 8. I don't have room to go down 3/4. You can always switch both signs of your slope. So instead of going down and right, I could also go up 3 and left 4. Basically, that's just putting the negative on the bottom instead of the top, but you can see how it just continues that line. Okay, so then we can take a ruler, which I seem to have lost mine momentarily here. Okay, so we can take our ruler or some kind of straight edge, use your ID card or another sheet of paper just to make a nice line. Go right through the center of those points, make a nice line, and then we always want to label with our equation. Okay, so there's my graph of y equals negative 3/4 x plus 2. I can see that my y-intercept is 2. I can see negative 3/4, down 3 over 4. It's really easy for me to check. Also, again, remember with those slopes, negative 3 over 4, it's a negative slope. Can I make an n with this? Yes, that tells me it's slanted in the correct direction. Okay, let's do one more. So the next one is 3x minus 2y equals 2. So this one, I do have to put it into slope-intercept form. So 3x minus 2y equals 2. So I want to get y by itself. I need to subtract 3x from both sides. Again, on the right side, remember that those are not like terms, so I have to keep them separate, and I want to put the x term first. Divide by negative 2. So y equals 3/2 x minus 1. Watch your signs. So my slope is going to be 3 over 2. My y-intercept is negative 1. So rise over run. These are both positive. That tells me I'm going to go up 3 and right 2. So if I go ahead and graph this, my y-intercept is negative 1 this time, negative 1 here on the y-axis. And then my slope is 3 over 2, rise over run. So up 3, right 2, from this point, not from the origin, from this point. So up 3 over 2, up 3, right 2. Okay, again, connect it with my straight edge, and then I'm going to label it. Now when I label this one, I have two choices. I can either, whoops, my straight edge moved. I can either label it with the y equals mx plus b version of the equation, or I can label it with the original. I generally label it with the slope-intercept form, because then also it's so easy to see if you have it right, because from there I can say, okay, there's negative 1, up 3 over 2, up 3 over 2. Okay, so the rest of the notes packet, pages 4 through 8, are really just a bunch of examples to try, okay? The 4 through 7 are all graphing like this. Page 8 has some more finding the slope. So I am, again, not going to go through all of them on video. I'm going to scan, hopefully, scan and upload those notes. If I can't scan them in, I will just take pictures and post those, but I'm hoping to be able to scan it. And the answers will be on there. And then Thursday's Zoom session will really be just anyone that has any questions. Any of them that you want to go over, I'll be happy to. But you can just go ahead and ask for those. Okay. The Chapter 6 homework is up. The Chapter 6 test will be up by tomorrow. It will, actually won't be available to you guys till Friday. So I'll have it done by tomorrow, but it will be available for you from 6 a.m. Friday through Sunday night. And same thing as before, whenever you start it, you then have an hour to finish it. Okay. Again, also, if you need extensions on anything, just let me know. Okay. I have deadlines so we can kind of keep moving forward, but I also understand that people are dealing with a lot. So if you need an extension on anything, just let me know and I will open that up for you. Okay. All right. So take care and email me if you have any questions. All right. Thanks, guys.